So now for some fun with exponents and use some logarithms. In order to solve for an exponent, here we've got a z as 3z as the exponent. In order to solve for an exponent, we need to use logarithms. With this one, I'm going to be using natural log because that's the opposite or the inverse of the e function. But first, I need to get rid of the 8. So divide both sides by 8. E to the 3z is equal to 3 when you divide both sides by 8. And then take natural log of both sides. So the natural log and the e will cancel each other out. We have just 3z on the left side. And then the natural log of 3. And then just divide both sides by 3. So z will equal the natural log of 3 divided by a 3. And then I'll go ahead and get a decimal answer for that. The natural log of 3 divided by 3, 0.366. All right, the first one's done. Now, for this one, we're going to be using the natural log again, and again we need to get rid of this number that's in the front. So first, divide both sides by 800. Let's see, I could reduce this a little bit. The hundreds will cancel, and then an 18 and an 8 are both even, so divide by 2. And divide by 2. And then this part, leave it exactly as it is. Don't get a decimal estimate for this. Just leave it as it is. We'll type the whole thing in the calculator in a moment and get the most accurate answer possible. The next step is use logarithm. You can use whichever logarithm you want. I'm going to use natural log. The reason for doing this is there's a rule of logarithms that says you can take this exponent 2t, bring it down in front of the natural logarithm, and multiply. So the left side stays the natural log of 7 divided by 4. The 2t is brought down in front of the logarithm. And then, in order to solve for t, we just have to divide both sides by 2 and divide both sides by this natural logarithm. So all of this other stuff is going to be shifted to the bottom over here. So then we would have t on this side, and then just make it one big fraction. The natural log of 7/4 is on the top, and then we divide both sides by 2. And divide both sides by this logarithm right here. Okay, now it's time to get the decimal answer for that one. So we would have the natural log of 7 divided by 4, there's the numerator, divided by, now the denominator has more than one thing in it, so I need to put parentheses around it. So in the calculator, I need to put parentheses around all of this to let the calculator know that's in the denominator. There's 2, the natural log of 1 plus 0.06 divided by 2, and then close one parenthesis, and then close the last parenthesis. So there would be the answer, decimal form, 9.466. Look at that, we're already halfway done. So what's the difference between the one that we just did and this one? Well, with this one, we're not solving for an exponent. This is a 10. That's not what we're solving for. So this one does not require logarithms. Instead, well, think about this. If this was square, then what we would do is move the 50 out of the way and then take square root. Well, we do the same thing, except it's not square root, it's going to be 10th root. First, move the 50 out of the way, divide both sides by 50. On the left, that's going to be a 4. And then in order to get rid of a 10th power, use a 10th root. And then because we're taking an even root, then we need to put plus and minus. So with this one, the 10th root, so there's two ways to do it. You can go 4 is raised to the 1/10th power, or you can go 10, then math, and this one right here is the root. So that's going to be the 10th root of 4. Either way you look at it, it's 1.149. So plus minus 1.149. Now we just need to subtract 1 from both sides. So r is going to equal -1 plus or minus 1.149. So how much is that? -1 plus 1.149, and the same thing with subtraction. So a positive 149 or negative 2.149. All right, then for this one, well, this one can be done in a couple of ways. You could use logarithm, much like I did this problem right here, or this one you can actually do without logarithms because 4 has a base of 2, it's 2 squared. 32 is also a base of 2. So this you could rewrite it as 1 over 2 squared. And then this you could write as, let's see, how many 2's does it take to make a 32? 2, 4, 8, 16, 32. It takes 2 to the 5th. And then what you could do is even rewrite this as 2 to the -2 rather than using a fraction. And the idea is once the bases are the same, the 2 and the 2, then the exponents have to be the same. So the exponent over here, you have to multiply these two, is -2x. That will have to equal the exponent on the other side, which is a 5. And then finally, just divide. It's going to be -5 halves, or I guess you could use -2.5 if you wanted.